Hello and welcome back to Handheld Coding OPL. So I hope after this short break you've not given up on your coding dreams and have been practicing all the things that we've looked at. Today we're looking at how to design more complex programs using subroutines. So first of all, what even is a subroutine? So a subroutine is a small program, although it doesn't have to be small, that runs within another program and is effectively called upon by the main program when needed. For a subroutine to work properly, we need to be able to return something from the subroutine, and we need to push information to the subroutine. Since subroutines are small programs, they follow the same nomenclature as normal programs, 8 characters, and then a symbol after them to indicate if it's an integer or a string, and of course floating points don't require a symbol. So to get a feel for what a subroutine is or does, we're going to write a short piece of code just to demonstrate how to grab information back from a subroutine. So here's the code for the initial main program, SUBR or subroutine. So as you can see, I've created 3 variables to demonstrate floating point with an F, integer with an I, although I haven't specified it as an integer, and I'll show you why in a moment, and finally S for string. I've made it 6 characters long, so we can use the word string. It prints test ready, then pauses for half a second, and then you can see our first floating point. So we've got F equals FLO, and then a single colon. So a single colon is what we use to define a program, so the name of the program and a single colon, and this works very much like a label. So once you reach this and it says FLO single colon, the Psion then jumps to look for a second program called FLO. Just to be clear, these are slightly different on the series 2 to the series 3 and 5, and I'll come to that in a moment as we finalize the rest of the subroutine. After that, it clears the screen, prints floating point, and then we get our resultant F or floating point. So before we jump ahead and look at the other 2, let's look at our subroutine. So our subroutine on the series 2 is written as a completely separate file. So we need to create a new code called FLO. After that, we're going to return a floating point variable, and I've decided to generate it as a random number. So we've got return 1 plus RND multiplied by 6. So this is the same code that we use in our dice roller, but because it's a floating point, we should get 12 decimal places after it. On the series 3 and 5, instead of having a completely separate file and the Psion looking around for that piece of code somewhere scattered among the rest of the files, it's actually contained within the same file. So underneath your main code, you'll write a new piece of code, and it starts the same as the original. So it'll be PROC for procedure, then the name followed by a single colon, then the code itself, and then end P for end procedure. There are advantages to having it as part of the same file. Obviously, it means if you have multiple programs using the same piece of code or the same subroutine, you have to copy it into multiple files. But it saves cluttering up the file system as you would on the series 2 by having all these subroutines scattered about. So swings and roundabouts on that one, but that's how they differ. So in our subroutine, the return command will return any number that is written after it, the value of any variable that is written after it, or the sum of any equation written after it, assuming that it accepts numbers, i.e. it's a floating point or it's an integer. If it's a string, whatever you want to return either needs to be a string variable or it needs to sit in quotation brackets as an actual string. Going back to the main code, at this point it will print the random integer that we've just created. Next it pauses for a second, clears the screen, and then we get I, which is our integer, equals int%. And because we've made our subroutine with the percent symbol, it will only return an integer. We can see this when we look at its subroutine here. It's named int%, which means it returns an integer. Then we return, and we've used the same piece of code as we used for our floating point variable. But because we've defined this subroutine as an integer, it will ignore all the following decimal places. Next it prints integer, so we know what it's doing, prints the integer, I, pauses 20 seconds, clears the screen, and then we come to the string. So the string subroutine is named str, with the $sign to define it as a string, and as you can see, it just returns the word string. It then pauses for 20 seconds and ends the program. So this shows you how a subroutine can return information to our main program. Okay, so that's great. We can now get information from a subroutine, but sometimes we need to pass information to a subroutine. And there are two ways of doing this. So for this example, we're going to use a new program called pass, and we're going to write a subroutine called rnd%. So it will return a random integer. We're going to look at the subroutine itself first. We've named it rnd%. Immediately after the colon, we've put some brackets and an integer variable n%. The name of this variable isn't relevant, but whether it has a % or not is. Because it has a % we can only pass an integer. After that, we've put our random d6 generator, so we return 1 plus rnd multiplied by 6. Because we've specified this subroutine as an integer, it will only pass a whole number back to the program. So next, let's look at our main program. We're going to call it pass. We're going to create two local variables, ns for number of sides and r for roll. I've set ns as an integer, but I've left r as a floating point variable, not because I'm a lazy programmer, but just to demonstrate that we don't need to specify it as an integer. Next, we print number of sides, input equals ns%, and then we come to our subroutine. So r equals rnd%, colon, and then in brackets, we've passed the ns integer to our subroutine. So in those brackets, the number that we're passing could be an actual number, it could be a floating point variable, or in this case, it could be the integer ns. The program then jumps to our subroutine. In our subroutine, n% is substituted for nr%, or our number of rolls. In this case, let's say 6, and then n% is substituted for 6 in our equation. So it will randomly roll a number between 1 and 6. Jumping back to the main program, it returns that number as r, clears the screen, prints r, and then we've got get to pause the program. So that's the first way that we can pass information to a subroutine. The second way we can pass information to a subroutine is to simply make the variable a global variable. So far in this course, we've only used local variables, and local variables only apply within the stretch of code that they are defined. So you couldn't, for example, define nr as a local variable in your main routine and then specify it in the subroutine. This would instead return an error message. However, if we make it a global variable, then that means that when the main program is launched, all subroutines will have access to that variable. They'll be able to pull information from it, manipulate it, and return it. This can be very useful when writing programs such as games, where there are lots of things going on screen at once. So now we can rewrite our program pass, and instead of having ns as a local variable, we simply make it a global variable. In our subroutine, we don't need any brackets after the colon following the name. Instead, we can simply put ns% at the end of our calculation. So now our code looks like this, and as you can see, when we reach r, it simply equals rnd%, jumps to rnd%, where it returns nr back as a random number. So now we've got a handle on subroutines. Let's create a useful program that will be able to calculate the voltage, current, or resistance of any circuit. Before we jump in and start typing code and creating subroutines, it is very useful at this point to start with a planning stage. One of the easiest methods for planning programs, particularly when you start using subroutines, is to simply create a flowchart of what you want. I generally structure my programs as a main program, which contains all the menus and then jumps to the various subroutines that do actions within that program. That means the main program is relatively short, the subroutines can be tested individually, which makes debugging much easier, and when you come back to them, it's quite clear what each part does. So in our random number generator, for example, our flowchart might look like this. Start, input number of sides, calculate an output, and end program. So that's a pretty linear program, and now what we're going to do is something a little bit more complicated. So in the case of our new program VIR, it might look something more like this. So we've got the start, then we choose what we're calculating, so it'll be one of these three, then we output, then do we want to do it again? If we do, it goes back to the beginning. If we don't, we'll end program. Please feel free to pause the video here and have a go. At this point, because of the complexities of what we've learned, there are now multiple ways of doing any one of those steps. So don't worry if your program doesn't look anything like the one I come up with. As long as it works, it doesn't really matter. But here's how I've done it. So as you can see, I've decided to use global units, and I've done that because it saves me writing local units in each of the subroutines, and therefore I write one line of code and save three. The variables I have are units, and this is of course a string variable up to 5 characters because we've got volts, ohms and amps. I then have 3 floating point variables, VRC standing for volts, resistance and current. After that I've defined 2 local variables, $, which you've probably realized is for the menu, and then out, which is our output. We've got our start label so we can come back to the beginning easily, and then the simple question, volt, resistance or current. So at this point, if you press V, then our output variable out is going to be equal to our subroutine volt. There are 2 other options. You can press R or you can press C, and those will take you to the output for resistance and the output for current. So let's have a quick look at our subroutine volt before we come back to the main program. So voltage equals current multiplied by resistance. So we're going to need those 2 variables. I've not defined any local variables, and that's because we're using a global variable in the main program to pass the information to and from our subroutine. So the first thing we're going to do is define the current, which is C. Then we define the resistance, which is R. We're going to define the global variable units, and this time it's going to be outputted in volts. And we're going to return the value of C multiplied by R, which will equal our voltage. Jumping back to the main program, the screen is now cleared and it prints out, which is going to be our voltage, followed by our unit. It then waits until you press a button, clears the screen, and we reach the menu to return to the beginning. The other 2 subroutines work in exactly the same way. They both ask for the inputs that we need, specify the units that we're going to output, and then returns the value back to the main program. As I say, there are a great many ways you could have achieved the same thing. You could, for example, have specified the variables required in each subroutine. You could have specified the units as part of the if-else-if, following the choice on what we were using as opposed to specifying it in the subroutine itself. And of course, you could have simply written this as a completely linear program. So I hope you can see the value in subroutines and that you've enjoyed this episode. If you have, don't forget to hit like and subscribe. In the next episode, we're bringing a whole new dimension to our programs. We're going to look at what we can do with time and also create sound. So if you are enjoying them, don't forget to hit the notification bell so you don't miss that episode. As always, all the code from today is available for download below. And if you have any feedback on this course or on the channel in general, don't hesitate to pop some feedback below in the comment section. As always, my name's Hugh. This is Handheld Coding OPL. Thanks for watching.